So in the first question, I give you the formula of 4 different compounds and I ask how many elements and how many atoms. When you're doing elements, it's really straightforward. You just count how many capital letters you've got. So in the first one, you've got a capital K and then a capital B. The capital K is for potassium and the capital B with the lowercase r is for bromine. So you've got 2 different elements, potassium and bromine. The next one, you've got a capital H for hydrogen, an S for sulfur and an O for oxygen. The fact that you've got 3 capital letters tells you you've got 3 separate elements. And the next one, you've got a Ca for calcium, an O for oxygen, and an H for hydrogen. Again, 3 separate capital letters, 3 different elements. And at the end, you've got Mg for magnesium, an N for nitrogen, and an O for oxygen. 3 separate capital letters, 3 separate elements. When you're looking at how many atoms, you're going to have to use the numbers in the formula. There's no number after K, which tells you you've just got 1 potassium. There's no number after Br, which tells you you've got 1 bromine. In H2SO4, you do have numbers. So you've got the number 2 after the H. That tells you you've got 2 hydrogen atoms. There's no number after S, so you've just got 1 sulfur. There's a 4 after O, so you've got 4 oxygens. Add them all together and you've got 7 atoms in total. The next one, you've got a bracket. There's no number after calcium, and calcium is not inside the bracket, so you've just got 1 calcium. Oxygen is in the bracket, there's a 2 outside the bracket, so you've got 2 oxygens. You multiply what's inside the bracket by what's outside the bracket. Hydrogen, there's 1 hydrogen in the bracket, a 2 outside the bracket, that means you've got 2 hydrogens. So 2 hydrogens, 2 oxygens, 1 calcium, 5 atoms in total. The next one, magnesium, is not within the bracket. There is no number after magnesium, so you've just got 1 magnesium. Nitrogen's in the bracket. There's a 2 outside the bracket, so you've got 2 nitrogen atoms. And then here you've got 3 oxygens in the bracket, and you've got a 2 outside the bracket. Remember, you're always multiplying. Brackets mean multiply, so it's 2 times 3 is 6 oxygens. So I've got 6 and 2 and 1. I've got 9 atoms in total. In the next question, you are asked to calculate relative formula mass using the same formulas. Relative formula mass, you take the mass of each atom and you add it together. So in potassium bromide, we've got 1 potassium with a mass of 39, 1 bromine with a mass of 80. I add those 2 together and I get 119. These numbers were provided to you in the question, and that usually is the way. If they were not provided to you, you would find them on the periodic table. The mass is the bigger of the 2 number on the periodic table. The next one, sulfuric acid. I've got 2 hydrogens this time, so I've got 1 plus 1, 2 hydrogens. I've got a sulfur, which is 32, and then I've got 4 oxygens. So each oxygen has a mass of 16, but you've got 4 of them. That's why I've got 16 times 4. Add up all of that and I get a total mass of 98. In the next one, I've got calcium hydroxide. I've got 1 calcium with a mass of 40. I've got 2 oxygens. Remember, oxygen's in the bracket. It's multiplied by 2. So I've got 2 oxygens, and each oxygen has a mass of 16. And I've got 2 hydrogens. Each hydrogen has a mass of 1. I add all of that together, and I get 74. The last one, MgNO3 times 2. I've got 1 magnesium with a mass of 24. I've got 2 nitrogens, each with a mass of 14. And I've got 2 times 3, 6 oxygens, each with a mass of 16. Add all of that together and I get 148. Make sure that you are adding the masses together. You're not multiplying all of the masses. You're trying to find the total mass. It'd be like if you were trying to find the total amount of money in your purse. You would add the value of the coins. You wouldn't multiply them. It's the same here. If you're trying to find the total, you are adding, not multiplying. And these are the numbers that you should get. In D, you are asked for the empirical formula. So empirical is the simplest whole number ratio. So if I look at the first one, this is my molecular formula. And my molecular formula tells me I've got 5 carbon atoms and 10 hydrogen atoms. I want to get that in the simplest whole number ratio. So I look at the 2 numbers in my formula, 5 and 10, and I ask myself, what is the biggest number that will divide into 5 and into 10 evenly? And the biggest number is 5 itself. So I'm going to be dividing by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. The next one, the numbers are 20 and 42. The biggest number that will divide in evenly is 2. 20 divided by 2 is 10. 42 divided by 2 is 21. The next one, C4H8O2. I've got 3 numbers this time, and I need a number that will divide evenly into all 3 numbers. Again, the biggest number is 2. 4 divided by 2 is 2. 8 divided by 2 is 4. 2 divided by 2 is 1. And that is the empirical formula. They can also ask you to calculate empirical formula using mass. If they do, it'll be typically a 3 or a 4 mark question. So in question 5, in the question you are given the mass of calcium and the mass of chlorine. So I've gotten these numbers straight from the questions. You are also given the mass number from the periodic table. So 40 for calcium, 35.5 for chlorine. Your first step is divide the mass in grams by the mass from the periodic table for both. Okay, and when you do that, you get 0.03 for calcium and 0.06 for chlorine. So it's just 1.203 divided by 40 and then 2.13 divided by 35.5. Again, these two numbers coming from the question, these numbers also in the question, but they can also be found on the periodic table. Once I've done this, I have got a ratio 0.03 to 0.06, but I need to turn this ratio into a whole number ratio. The easiest way to get rid of the decimals is look at these two numbers and ask yourself which is smaller. 0.03 is smaller than 0.06. So what I do is I divide both of these numbers by 0.03. When I do this, I get 1 and I get 2. Now I've got the ratio and it's in whole numbers. I'm ready to write my formula. The 1 refers to the calcium, the 2 refers to the chlorine, so my formula is CaCl2, so 1 calcium, 2 chlorines. The other way they can ask this question is instead of giving you the mass in grams, they'll give you the mass as a percentage. So in the next example, I was given it as a percentage. These were the 3 percentages. Instead of having just 2 elements, I've now got 3. That doesn't change anything. So I write the 3 percentages, and then I take the mass number from the periodic table. Again, this was given to you in the question. 40 for calcium, 14 for nitrogen, 16 for oxygen. And just as above, I divide. Okay? So when I divide, these are the 3 numbers that I get. And again, I've now got 3 numbers that all are to decimal places. I need to make these whole numbers. And to do this, I look at my 3 numbers and I ask myself which is smallest. 0.7588 is the smallest of the 3 numbers. So I divide all of them by 0.7588. When I do this, I get 1:2:4. So I now have whole numbers. I've gotten rid of all of my decimal places. I can now write the formula. The 1 refers to the calcium, the 2 refers to the nitrogen, the 4 refers to the oxygen. So putting that all together, this is my empirical formula. Make sure you write down the right symbol for the element. So for example here, if you wrote C for calcium instead of Ca, if you didn't use your periodic table, you would lose that final mark. So rather than assuming you know the right symbol, have a look on your periodic table and make sure you've got the right symbol for the right element. So you can be given it as a mass in grams or as a percentage. It does not change how you do it. You divide by the mass number, you simplify the ratio into whole numbers, you then write the formula. Using this table, you won't go wrong. And the next question, the first part of it, you are asked to find the empirical formula. Again, I've got 3 elements, carbon, hydrogen, and oxygen. And again, I'm given the percentages. I'm also given the mass numbers from the periodic table. My first step is to divide. These are the 3 numbers I get. To get rid of these decimal places, I look at the 3 numbers and ask which one is smallest. 3.3 is the smallest of the 3 numbers, so I divide everything by 3.3 and I end up with a ratio of 1:2:1. The 1 refers to the carbon, the 2 refers to the hydrogen, the 1 refers to the oxygen. This is my empirical formula. In 7 part B, you are asked to use that empirical formula to find the molecular formula. If you're asked to find the molecular formula, there are 3 steps. Step 1 is to get the relative formula mass of the empirical formula. So we've just calculated the empirical formula, CH2O. I now need to get the relative formula mass. I've got 1 carbon with a mass of 12. I've got 2 hydrogens, each with a mass of 1. I've got 1 oxygen with a mass of 16. These numbers I'm getting from the periodic table. I add the masses together and I get 30. In the question, you are told that the formula mass of the whole molecule is 180. So this number I'm given in the question, I take this number 180 and divide by my answer to step 1, which is 30. 180 divided by 30 is 6, okay? You should always get a whole number here. So if you end up with a decimal point or a number less than 1, you have done it the wrong way around. It should be the number in the question divided by your answer to step 1. You should always get a whole number. In this case, it is 6. I then take my empirical formula, which I've calculated here in 7a and used in the first step. I take this empirical formula and I multiply by my answer to step 2, which is 6. 6 carbons gives me C6. 6 times 2 is 12 hydrogens, 6 times 1 is 6 oxygens. My molecular formula is C6H12O6. This tells me that my molecule is glucose. That's my molecular formula. In 8, 9 and 10, you are looking at concentration. You are asked for the concentration, which I'll show you this. You are asked for the concentration in grams per decimeters cubed. If you look at the volume that you are given in the question, you will see that it is not in the units decimeters cubed. It is actually in the units centimeters cubed. So before you calculate concentration, you need to do a unit conversion. You have to take what's in centimeters cubed and convert it to decimeters cubed. To do this, you will divide by 1000. So this is the volume in centimeters cubed. Divide by 1000. You now have the volume in decimeters cubed. You are told that you've got 400 grams. You're given this information in the question. Your mass is already in the right unit. So grams and grams, you don't need to do a unit conversion there. The volume, you had it in centimeters cubed, but you've now got it in decimeters cubed. So you've just got 400 divided by 2.3 equals 173.9 grams per decimeters cubed. If you're struggling to remember which way around to divide, just look at the unit. The unit is literally grams divided by decimeters cubed. So that's mass divided by volume. When you're doing this, you should be doing the same. The grams should be on top. The decimeters cubed should be on the bottom, and this is the answer you will get. And the next question, again, you're asked for an answer in grams per decimeters cubed. Again, you're given the mass in grams, so that's fine, but you're not given the volume in decimeters cubed. You're given it in centimeters cubed. So as with question 8, your first step is going to be a unit conversion. Centimeters cubed to decimeters cubed means you have to divide by 1000. Now I've got my mass in the correct units, I've got my volume in the correct units, and it's grams divided by decimeters cubed, which is 212 divided by 0.5424 grams per decimeters cubed. Again, you get the formula from the unit, and the unit is given to you in the question. The mass divided by the volume. The mass must be in grams, which it already is in the question. The volume must be in decimeters cubed, which is why you have to do this first step. In the last question, it's a slightly longer because again, you are asked for the answer in grams per decimeters cubed. You are given the volume in centimeters cubed, so you must go from centimeters cubed to decimeters cubed. Again, you divide by 1000 to do that. This time, however, you're not given the mass in grams, you're given the mass in kilograms. So you're going to have to convert from kilograms to grams. To do this, you multiply by 1000. Now I have the volume in decimeters cubed, I have the mass in grams, and then using the unit that I've been supplied in the question, I can see that it's grams divided by decimeters cubed, which is 625 divided by 1.4, and this is my final answer, okay? It's really important that you can do your unit conversions, okay? From centimeters cubed to decimeters cubed, it's the same as going from milliliters to liters, and your number should get smaller, okay? So if you had 500 milliliters, that's only half a litre. The number is less in litres. But when you're going from kilograms to grams, because a gram is smaller than a kilogram, your number should be getting bigger. So you should be multiplying by 1000 when you're converting to grams. So please just make sure that you are familiar with which way around you should be doing your unit conversions. Other than that, because they give you the unit in the question, you shouldn't really have to memorize the formula. It's given to you in the question. If you've got any other questions about these, just message me and let me know.